Hey guys, so now we're going to talk about inverse functions. There are four ways to represent inverse functions. And the inverse function is represented, this is how we normally write functions, f of x, and we write it f to the negative 1 of x. So that's just how we write it. Whenever you see that little negative 1, that means inverse. So I have a regular function f of x, and then I have f to the negative 1 of x. And that's what that little negative 1 means. It means inverse. You see that button on your calculator, that means the inverse of something. There are four ways, like I said, to represent it. Ordered pairs is a pretty easy way. Okay, all you do is you switch them. The x and the y switch. All right, so if this is our original function, okay, then if x is 1 and y is 2, we switch it. X is 2 and y is 1. If x is 0, y is 4, we switch it. And here, we also switch them. So these just switch, x and y switch, and that's going to be a pattern throughout here. So if you want to remember, the main thing you do is switch x and y. All right? In the next one, it's very, very similar. When you switch the x and the y, like we did for our table, our ordered pairs, it actually ends up making any type of graph that you have, it makes it reverse or mirror image, I've seen it called. So since this, I just made just a random curve, and we're going to be more specific when we practice, but we take this curve and it's going to flip. It's going to be a mirror image, and it's always around this equation. This equation is y equals x. That's just that general equation. And it's always just going to flip over that y equals x. So if this is the original graph of just any function, just this curve, in general, the inverse will be the flip. So it's like I take a piece of paper and I fold it, and it's going to look something like that. It's not going to be quite as close because that one wasn't quite as close, but since I'm just doing it by hand, so I just take it and I flip it to the other side. And when we do some examples, you'll see the points and how they actually flip around this equation, y equals x. And we don't, that line is just kind of a boundary line. It just helps us kind of know where it's going to flip. It's not a part of the function. All right, for an equation, we still keep in mind that we switch. We switch x and y. We switch the values for x and y. So if our original function is y equals x plus 5, what we do to find its inverse is we actually switch the x and the y. So I take this y and this x and I move their places. So instead of y equals x plus 5, I'm going to literally switch them to x equals y plus 5. So the first thing I do is I switch them. Just like I kept in mind that I switch here, I switched them here. The only thing you have to add right here is that you still need to, it still needs to begin with y equals. So from here you have to solve for y. So since y is not by itself, I have to subtract 5 to the other side. That way it goes away on this side and it shows up over here. So that would be x minus 5. And y is by itself, and since that looks a little funny, typically we lead with y. Our symmetric property says we can switch it. So this is the original function y equals x plus 5. Its inverse is y equals x minus 5. And they don't always look quite that simple, but we'll practice with some of them. And then the last one, I actually gave you that these are inverses. X minus 4 and x plus 4. They are inverses. I went off to the side and I did this, okay? And what you can do to show that they are inverses is use composition, which is just the long word or the noun for a composite function. So we actually can put this function inside of this function, and we should get a certain type of answer. So if I take f of its inverse of x, okay, f of the inverse of x, okay, so that means I take f of x, which is right here, x minus 4, I take out the x, just like I normally would take whatever this is, and I would take out the x. And since the inverse is x plus 4, just like we've done with other composite functions, I'm going to put x plus 4 in its place. And then we get plus 4 and minus 4. They cancel out. A positive 4 and a negative 4 cancel out. So we're really just left with the value x. Well, if we were to do it the other way, f of the inverse of f of x. Okay, so now I'm going to put this function inside of this one. The inverse function is x plus 4. I'm going to take out the x, and just like I've done for all composite functions, since the f of x function is x minus 4, that is what I'm going to put in place of where I had that x. And again, if you notice, negative 4 and positive 4 cancel out, so I'm left with just my x. When you are left with x, that means that they are inverses. So you always get equals x, and that's all you get. If you have anything else, you know that they're not inverse functions. But since I did it one way, I got x. Since I did it the other way, I also got x. So that proves to me that these are inverses, because when we do one composite into the other and in reverse, they all work out to an x. And that's always what you're going for when it comes to composite functions. Excuse me, when you're using composite functions with inverses.